Yes, good morning, students.
Good morning, sir.
Some students are, yeah, some students are still joining. We'll wait for a minute. I hope all of you have marked your attendance. I have already enabled it. If not, mark your attendance. Okay, so let us take a quick review of what we discussed in the last class. In the last class, the slides were not available. Uh, so this we discussed the system clock is one of the parameter for comparing the performance, but it is inadequate because two or more computers may have the same system clock. Okay. Then we discussed that CPI is one of the parameter that can be used to measure the performance, but CPI for all the instructions it is not same. So we calculate average CPI using this particular formula. CPI it stands for cycles per instruction. So it is desired that CPI for a particular computer should be less so that the performance of that particular computer is better than the other computers. Then uh, the time required for execution of a particular program can be computed like this. Of course, the time required for execution of the program and CPI, they are more or less the same or similar parameters. Uh, the time required for execution of the program can be calculated with the help of this formula. That is, T is equal to IC, IC being the total number of instructions into uh, P. That is, P is the number of processor cycles needed to decode and execute the instruction. So, and M is the number of memory references needed. Okay, so P refers to the internal operation of the CPU, whereas M refers to the external operation. Memory operation is said to be the external operation. Usually, more time is required for performing external operation, the operations that are related to memory, whereas K is the ratio between the memory cycle time and the processor cycle time. Okay, so that is the how many instructions are of the memory type and how many instructions they are to be executed inside the processor. And once you calculate these number of cycles, then for all the instruction it is multiplied by the time period of one clock, and from that you get the total time required for execution of the program. So this is another formula you may like to need to refer while calculating the performance of the computer. Uh, so we can uh, you can refer to this particular matrix which defines which particular parameter or which feature of the processor or computer is related to the parameter in the total time required for execution of the program. Okay, the instruction count for a particular program, it can be less or more. Okay, so even it is not same on all the computers. The instruction count is not same. Why? Because the instruction set of every processor is different. So different number of instructions are required depending on the instruction set and architecture of that particular computer. Okay, so every microprocessor has got its own instruction set. Okay, like you know that the higher level languages, that is C++, Java, so these instructions, the higher level language, it is same. Even if you are, this particular programs are same, even if you are executing this particular program on one computer or the other computer, but that is not the case with the low level program. The low level program for all the computers types, it is different. Okay, so for Intel computers, the computers based on Intel, the low level program is different, whereas for the computers which are based on the Motorola processors, their low level program is different. So the number of, if the program is different, the instruction count IC, that will be different, though the same group of instruction is doing some intended task. For example, it may be sorting of certain numbers. Okay, so this is the task, and this particular task can be implemented on the Intel processor or it can be implemented on Motorola processor, but the number of instructions required to implement this particular task, it may be different for the different processor. So the IC changes. Okay, P, that is the internal cycle time, so that is again different. So internal architecture defines how many cycles or internal cycles are required for execution of the instruction. Okay, then the compiler technology affects again the number of instruction. Okay, so if some compiler, job of the compiler is to convert the higher level language. Usually we do not write directly into the low level language instructions. So a compiler converts the high level language instruction into the low level language instruction. So if the compiler is good enough to make the low level program as compact as possible, then in that case the IC reduces the number of instructions, the instructions that are chosen for the purpose of performing the internal operations. If they are properly chosen, then this P also reduces, or the memory references also reduces if the instructions of the low level language are wisely chosen by the compiler which is being used. Okay, so the compiler technology also matters in the computers. Okay, the processor implementation, the overall implementation of the processor, which technology is being used, VLSI, ultra VLSI, or like that. Okay, so the instructions internal computation affects, and of course what is the time of one clock, that also affect. Okay, so the clock frequency on which your processor can be operated, so that is defined by this particular tau. Okay, whereas the cache memory, cache and the memory hierarchy, so that also matters. So how fast that particular memory is, and how many levels of hierarchy are there, so that also matters here. Okay, so like this, when you are designing a particular computer. So all these things, all these parameters, how is the instruction set of the processor, architecture, compiler technology, the processor implementation, the cache memory, and the memory hierarchy. That means how many levels of cache are there, and how is the final memory. So primary memory, how it is implemented. So that matters. So this is what is the system attributes that are compared with the execution of the program. Okay. After CPI, we discussed that one of the common performance for a processor is the rate at which the instructions are executed, and it is expressed as millions of instructions per second. So commonly it is called MIPS. So it is referred to as the MIPS rate. So we can express MIPS rate in terms of the clock rate and the CPI. So that is MIPS rate is equal to IC divided by T into 10 to the power 6, or the frequency at which the processor is operating divided by CPI into 10 to the power 6. So this is how we can calculate the MIPS rate for a particular processor. Okay, so yesterday in the last class we already discussed one example uh, to calculate the average CPI and to calculate the MIPS rate. Okay, so that example, this is the example that we discussed. The processor with which uh, was submitted to execute a program consisting of 2 million instructions operated on 400 megahertz, and there are four major types of instructions, and the instruction mix is given as in this particular table. Four types of instruction. The CPI for these types of instructions, they are 1, 2, 4, and 8, whereas the instruction mix is 60%, 18%, 12%, and 10%. Okay. In this, the point again to be noted here is that when the instructions are related to memory, then the time required for fetching the instruction, if the instruction is available in the cache memory, is only 2 cycles, whereas in the uh, if it is there in the primary memory, okay, so not there in the cache, then the cycles required are 8. Okay, so 4 times the time is increased. Okay, whereas the instructions which are there are to be executed inside the CPU itself. So for such instructions, the time required is the minimum time, that is only 1 cycle is required when the instruction is to be executed inside the processor. Okay. uh, then another parameter nowadays is very much important because the operations performed by the processor, they are not only the integer operations, they are the floating point operation, because nowadays we are using lot of uh, graphical user interface, and in that the floating point operations, or we are using the operations which are scientific operations, or based on the scientific data, or the data which needs high precision. So for that purpose, floating points numbers are being used, and that involves the floating point operations. So the instead of flops, the another parameter is also defined for the computer, that is M flops, that is million floating point operations per second. How many millions of floating point operations per second are executed by a particular processor can be calculated using this particular formula, that is number of executed floating point operation in a program divided by the execution time into 10 to the power 6. So that gives you the mflops rate for a particular processor, and you can compare the mflop rates for the different processors or computers, and you can then compare the performance of those computers. Okay. Now coming to the next point is the benchmarks for the computers. Okay, so there are certain benchmarks, and if you follow those particular, or if you use those particular benchmarks, then you'll be able to better compare the computers. Okay, so benchmark is nothing but certain standards. Okay, so if you compare any computer with a particular standard machine, because for comparing you need some standard. Okay, uh, so always, whenever a performance of a computer is to be evaluated, then it is evaluated with certain standard. Because if you are calling that my computer executes the 1,000 instructions per second or more than that, then which are those instructions, that also matters. Okay, because you will choose the instruction, you will choose some program which executes fast on your computer, and you will claim that see, this is my computer and it is executing these many instructions uh, on my computer. Okay, so for this purpose, usually what is done is that the program, the standard programs are being used. So if anyone wants to give the performance of the computer, then he or she cannot randomly choose the program of his or her wish, but you need to choose the program from the standard programs. Okay, so standard programs are being given, and from that you will be able to choose those particular programs, and such programs, they are called the benchmark programs. Okay, uh, here in the beginning, let us consider two different types of processors. Okay, because when you are working with the processor, then two major types of processors are there. One is of the type CISC, that is uh, complex instruction set computer. Okay, so this is one type of processor. So here in this case, you can see that certain program, okay, for example, if this is to be implemented, a is equal to b plus c, if it is to be implemented, then this can be done using the instructions add uh, memory B, memory C, and memory A. Okay, so that is add the contents of memory B with memory C and store the result in memory A. So you need a single instruction to perform this operation. A is equal to B plus C. You need a single instruction add the contents of memory B with, because this A, B, C are the memory variables, and add the memory B with memory C and store the result in memory A. So a single instruction is required on the on a computer which has the complex instruction set computer. Okay, so which is the CISC type of the computer. Okay, so the architecture of the CISC is different than the architecture of the RISC. Okay, what is RISC? RISC is reduced instruction set computer, or reduced instruction set computing machine. So this the compiler, it has got a simple architecture. RISC usually has the simple architecture and simple instructions. So the same operation, when it is to be performed, A is equal to B plus C on RISC type of processor, then you need more number of instruction. For example, you need a load instruction to load the contents of memory B into register A, register 1. Then you need to load the contents of memory into register 2. Then you need to add the contents of register 1 and register 2 and store that result in register 3. And finally, you need to store the contents of register 3 to the memory A. Okay, so the result is in the result is there in this particular register 3. Okay, so you need more number of instructions here. Okay, so and here the more number of instructions are there, and if you claim that my computer is executing more number of instruction, if it is RISC type of instruction, it is executing more number of instructions per second. But even if it is executing more number of instruction, what job it is doing? It is doing only A is equal to B plus C. Whereas this sys processor, it is executing only one instruction and it is doing the same job. Okay, so the for the sys type of processor, its one instruction is equivalent to the four instructions of RISC type of processor. So you cannot just compare the sys type of computer with RISC type of computer based on the flops, M flops, or you can say MIPS rate, or using the CPI rate, that is cycles per instruction, because the instructions of the CISC are complex, whereas the instructions of RISC processor, they are simple instructions. Okay, so the standard programs are designed. So what are the desirable benchmark characteristics, so that even if it is a sys type of processor or RISC type of processor, should not matter. Okay, so all these programs, they are written in high level language. Okay, so they are not written in any of the low level language. So from high level language, the program should be converted to the low level language, making it portable across the different machine. Okay, so the programs are written in high level languages. Then representative of a particular kind of programming style, such as system programming, numeric programming, or commercial programming. Okay, so the program should be, the benchmark program should be such that they are of the category system programming, or they should be of the category numerical programming. Usually the scientific purpose, this numerical programming are used, or the commercial programming, that are which are used in the business. Okay, then can be measured easily. Okay, so the execution time and other parameters should be able to measured easily, and has wide distribution. Okay, so this particular program uh, should be easily available for measuring the performance. So these are the desirable benchmark characteristics. Okay, SPEC, that is System Performance Evaluation Corporation. So this is the organization, and this particular organization, popularly called SPEC. So it has given benchmark suit. Okay, so this particular worldwide organization prepared certain programs, and those particular programs were commonly accepted for measuring the performance. Okay, so a collection of programs defined in a high level language. So benchmark suite consists of a collection of programs defined in a high level language. So it attempts to provide representative test of a computer in a particular application or system programming area. Then what is this spec? It is an industry consortium. So it is not a single company, but many company come together, and that forms the organization, that is industry consortium. Defines and maintains the best known collection of benchmark suits. So suits, it is nothing but the collection of programs. Performance measurements are widely used for comparison and research purposes. Okay, so that is the characteristics of this. One of the suit from the spec is spec CPU 2006, because it was introduced in 2006. So it is called CPU 2006. So its characteristics: best known spec benchmark suit, industry standard suit for processor uh, intensive applications. So the applications which are processor intensive, that is usually for the system programming, appropriate for measuring performance for applications that spend more of their time doing computation rather than IO. Then consists of 17 floating point programs in C and C++ and Fortran, and 12 integer programs written in C and C++. Okay, so it consists of total 29 programs. The suite consists of 29 programs. Of that, 17 programs you make use of the floating point numbers. Okay, those programs are written in the language C, C++, and and Fortran. Okay, so in various languages these programs are written, whereas the 12 programs are written in integer, which uses the integer data, and they are written in C and C++. Okay, the suite contains over 3 million lines of code. Okay, so this group of programs, it is 3 million lines of code. Okay, so these are the large programs. Then these are used for the fifth generation processor intensive suites for the spec. Okay, so this is the characteristics of this particular suite spec CPU 2006. Okay, so if you want to measure the performance of your computer, then what can you do is that you can execute these 17 floating point programs or 12 integer programs on your computer and find out what is the time required for execution of these programs on your computer. Okay, so this is how is that particular spec. Okay, so there are many other suits from the spec. You can refer to the book of William Stellings to get to know the other suits or other types of programs. Okay, then to measure the performance, then one of the important parameter or the measure or is to make use of the Amdahl's law to measure the performance or the of a particular computer. Typically, whenever you are going to upgrade your computer, okay, so what will be the effect of upgrading your computer on the performance of that particular computer is specified by the Amdahl's law. Okay, so it is by Jean Amdahl. So it deals with the potential speed up of uh, a program using multiple processors compared to a single processor. Okay, so if you want to increase the execution speed of your program, then what can you do? If the program is being executed by a single processor, then you can employ more than one processor. Okay, that means if the same program is given for execution, okay, for example, you may be knowing that now the CPU comes with multiple cores. What is that multiple cores? So it contains more than one CPU. The processor contains more than one CPU. That means simultaneously instructions are executed by the CPUs. Okay, so if CPUs are going to execute the instructions simultaneously, then the overall time required for execution of the program will reduce. Okay, so usually in the servers there are the rack of CPUs, okay, or the array of CPUs or array of processors, and because of that, in the supercomputers or the servers, main servers, the speed of execution of the programs is very high. Okay, so if you use multiple processor, then the time required for execution will be less. Okay, so you can reconfigure your computer such that you are using more number of processors so as to speed up your computer. Okay, so it illustrates the problem facing industry in the development of the multi-core machines. Okay, so what will happen if you are going to increase the number of processors? So that law uh, is being illustrated by this particular Amdahl's. Okay, so software must be adapted to highly parallel execution environment to exploit the power of the parallel processing. Okay, so many times it happens that simply by increasing the processor, you cannot increase the speed, because it should be possible. It should be possible to divide your program into those segments such that which can be executed simultaneously or parallelly. So this will happen if there is no dependency, or there is less dependency between the different parts of your program. Okay, if your program is dependent, if one segment of program is dependent on the others part of the program, then the one which is dependent cannot be executed unless the earlier part of the segment is executed. Okay, so the software must be such that it should adapt the parallel execution. Okay, so there should be less dependency, then only it would be possible to execute the different part of the program simultaneously. Okay, so you might have heard about the multi-threading or multitasking. So what is multi-threading or multitasking? Multi-threading is the execution of the simultaneous execution of the different parts of your program. Multitasking refers to execution of multiple tasks simultaneously. For example, on your computers, simultaneously you execute, you play some video, you open editor and you work on it, whereas the PowerPoint may be open and it may be doing something. Okay, so like that, multiple tasks are there and they are executed simultaneously. This is called multitasking. Whereas in the single program itself, if multiple threads are there, so for example, in the word processor, you are editing something at the same time. Some part of your document is being printed, whereas spell check is working in some part of your program. So this is somewhat something called a multi-threading. Okay, so parallel processing, we shall see later on in the last part of this particular subject. Okay, so that is one of the aspect. And how is the characteristics of your program, so that also matter. Okay, so if it is possible to execute the different part of your program simultaneously, then that will help to speed up the execution of the program. But if there is a dependency, if there is a lot of dependency, huge dependency between the different parts of your program, then even if you employ more number of processor, but you cannot execute those simultaneously. Why? Because there is lot of dependency between them. Okay, so Amdahl's law, it tells about the balance between, or the formula, or how your software it should be, and to what particular level you should increase your processors in that particular system. Okay, so it can be generalized to evaluate and design technical improvement in a particular computer system. Okay, so this is what is being specified by the Amdahl's law. Okay, the speed up is on the y-axis. Okay, so by increasing the number of processor, what you can do is that you can increase the speed of processor. Okay, for example, here you are having a single processor, only one processor. Okay, so your speed up is something here, which is 1. Let us say it is 1. Okay, if you are now using 10 processors. Okay, so you can see here, 10, you are using 10 processor, then as per the first curve, the your speed increases by almost approximately 5 times. Okay, so even if you are using 10 processor, your speed is not increased 10 times, it has increased 5 times. Okay, if you are using 100 processors, then how much is your speed increase? Your speed has increased 15 times. Okay, so though you are using 100 processor, it is not, the speed is not increased 100 times, it is increased 15 times. Okay, now after that, you are increasing, if you, even if you go on increasing your processor, the speed is not going to increase. Okay, so it is now saturating. So even if you are using 1000 processors, then your speed is will increase by 20. Okay, and even if you go for 1000 or 5000 or 10,000, then there won't be much increase in the speed. That means just increasing the number of processor will not increase the speed. Okay, whereas what are the other curves? The other curves, they specify the f. Okay, for example, here f is 0.95. Okay, so what is 0.95? F it is the factor or ratio which indicates how much part of your program can be executed in parallel. How much part of your program you can execute in parallel. Okay, so this indicates that 95% of your program, 95% of your program can be executed in parallel. Only 5% of the program can be is required to be executed serially. Okay, whereas for this particular curve, 90% of the program can be executed in parallel, whereas only 10% of the program can be should be executed serially. Okay, whereas if this EF indicate uh, 0.5, 0.75 indicate that only 75% of the program can be executed in parallel, and uh, 25 to be executed serially. Okay, so you can see that the speed up is not increasing. Okay, so if the parallelism, if uh, uh, the parallel, the part of the program which can be executed in parallel, if it increases, then the speed up also increases. Okay, whereas the bottommost curve, it shows that f is equal to 0.5. That means only 50% of the program can be executed in parallel, whereas the remaining 50% need to be executed serially. So in that case, even if you go on increasing the number of processors, then it is not going to increase the speed of the execution. It is just slightly increasing the speed of execution. So what is required is that the program which you are writing should be written, the programmer should take care that the program written is such that it can be executed in parallel. Okay, so it is the skill of writing the program, and that must be, if the programmer do not take this particular care, then the speed of execution of the program will be less. Okay, so it is not only the processor, but it is not only the computer, but the way you are writing the program, so that also matters. Okay, so that is why again uh, it is proven scientifically that how you write the program, there are different ways of writing the program. Okay, so if two persons are writing the program, then they will not be same, exactly same. So there will be some difference, number of instructions and all this thing, the logic implemented. So what matter is that how efficiently you are writing the program. Okay, so one is that your program should take less time to execute, but now in the coming days, the program should be written in such a way that it should be possible for the different part of your program to be executed simultaneously. Okay, so this is what is the Amdahl's law. Okay, little law we shall not go. It is not part of our syllabus. Okay, so I wanted to show you that particular formula. If it is available, I shall quickly show you. uh, Hello sir, I am in a class. हेलो, हेलो, मेरा क्लास चल रहा है मैडम. हेलो, 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 मूर्ति मैडम, तुझे कॉल कर. Okay, there was little disturbance because of the call. Uh, I hope I'm still audible. So Yes. So we have discussed the different parameters for the performance assessment or performance measurement. So any problem in this? I shall give you certain problems to solve on this so that it will be uh, easy for you. Yes, anything to be any problem with this? Am I audible?
Yes, sir.
Huh. So today we discussed about the benchmarks, that is spec, and later on the Amdahl's law. So any problem with that?
No, sir.
Hmm? Okay. So uh, I would just like to show you the Amdahl's law, the formula for that. I think already it is there in the notes which I have given you. Okay, already I have given you the notes, and in that this particular formula is available. So the formula is for the speed up. I hope this is visible to you. Speed f, it is the time. I will try to make it more clear. I think if I copy it on the slide. Okay, so this is the formula for speed up, that is time to execute program on a single processor and divided by the time to execute the program on n parallel processors. Okay, so this is the basic statement of the Amdahl, and you can put this in the form like this, that is T into 1 minus F plus T into F. What is F? F is the parallelism, the percentage of parallelism that you can introduce in your program. Okay, so if the uh, parallelism, okay, so or is it parallelism or uh, it is 1 minus F, so that is related to the seriality of the parallelity of the program. Okay, So f is related to that, okay, and it is divided by this, okay. So because there are n number of processors, uh, so here if n number of processors are there, then the time required, this particular time required, it will be this much, whereas this time can be reduced, okay. You cannot reduce the time 1 minus f, because this is the serial, 1 minus f is the serial part of the program and f is the parallel part of the program. So if one processor is there, the total time required would be this. But if n number of processors are there, this time cannot be reduced because this is to be executed serially. But this time can be reduced because you have n processors, so it is divided by n. So the time required using n processor would be this. So finally, you have this particular formula: 1 divided by 1 minus f plus f divided by n. So you can see here that even if you increase the number of processors, finally your speed up is limited. If you increase your number of your processor, what will happen? F divided by n. So this will come out to be 0, and finally your speed up will be 1 divided by 1 minus f. So that means how much part of your program is serial, so or how much part of your program is parallel. So that is determined, speed up is determined by how much part of your program is parallel, okay. So this is what is the Amdahl's law, okay. So we shall stop here, and next time we shall come with the next topic, the architecture of some processor. We shall see in the next class, okay. So you may now leave the class and join. It is time to join the next class, okay. So bye, good day.